Record. Okay, so the lesson today is about an area of mathematics called partitioning. Can you guys say partitioning?
Partitioning.
Now, doesn't it sound very much like making parts? Everybody make a part. Make parts. We're going to partition. We're going to make partitions. So if I were making parts for 45, isn't it easy to partition 45 to 40 and 5? And isn't it easy to partition 33 to 30 and 3?
Yeah.
And isn't it easy to connect the two 10 partitions, and 40 plus 30 is?
70. 70.
And 5 plus 3 is?
8. 8.
And of course, together they make?
78.
Of course. Now you can also partition the number 245 to be 240 and 5. 633. 630 and 3. And if you connect the 200 and the 600, you get what?
800.
40 and 30.
70.
And 5 and 3.
8.
Answer?
878.
Right. So that is what partitioning is all about. Now, what I want to do is I want to show you that there's some really interesting mathematics connected to computer science and math for partitions. And so let's look at partitioning the number 2. Do you notice how I always start with the number itself? And then what's another way to make 2 with addition?
1 plus 1.
So how many partitions are there?
2.
And Aaron, could you name the 2 partitions?
2 plus 0 and 1 plus 1.
I agree with that, but let's just say 2 and 1 plus 1. Now, how many partitions are there for the number 3? So I want to partition, go to a blank page, the number 3. What should I start with? Go.
1 plus 2.
Nope. What did I start with when I partitioned the number 2?
2.
So what should I start with when I'm partitioning the number 3?
3.
Now, in the next row, we never want to go to a lower number than we have to. What's the biggest number that can start the next partition?
2.
2 plus what?
1.
And raise your hand if you can see any other partitions. Go ahead, Tess.
1 plus 2.
Ah, now 1 plus 2 is the same partition as 2 plus 1. So if you remember from last week, 2 plus 1 is a combination, but 2 plus 1 and 2 and 1 plus 2, that's a different permutation. So we're not doing the different permutations today. We would just do 2 plus 1. So what is another partition test?
3 plus 0.
We've already got 3 plus 0 right there. So we don't want to repeat our partitions. I want to hear from somebody else. Come on. Come on, Avery. Come on, Sabrina. Come on, Aaron. Come on, Brennan. What's another way to make 3? Want to give it a shot, Sabrina?
1 plus 1 plus 1.
Of course. Tess, is that what you had?
No.
What do you have?
1.5 plus 1.5.
Ah, but when we partition, did you notice how we always break it up into easy to use whole numbers? So Tess, you are correct. That would add up to 3. And in fact, isn't there an infinite ways to add up to 3? Couldn't we do 100 plus negative 97? And wouldn't that also equal 3?
Yes.
But we're only using what's called whole numbers. Whole numbers are positive numbers or 0. How many partitions did we find for the number 3?
2. 3.
Who said
2. 3.
Who said 3? Who
3.
said Who said 3? Raise your hand. Okay, Brennan, why are there 3? Can you name them?
3 plus 3. 2 plus 1. 1 plus 1 plus 1.
So everybody go to page 3 in their packet. Now, notice that we already listed that the number of partitions for the number 2 was 2. You now know that the number of partitions for the number 3 is
3.
So write that down. And now what I would like you to do is this. We're going to let you look at the partitions for 3, but I want you to write down partitions for the number 4. And I want to see if you could find all the different partitions. So you guys do this on your own. And remember to do them in order the same way we did it here. Remember, the last partition will just be a bunch of 1s. And Avery, you already wrote it down?
What?
Did you already write down all your partitions?
No, I haven't done that yet.
Well, that's what you're supposed to be doing. Aaron, are you writing down your partitions?
Yeah.
Good. And Brennan, you've already got it done? And Sabrina, what about you? Are you writing down your partitions?
Yeah.
Great. And Tess as well. So I'm going to be interested to hear what Avery has to say about partitions for 4.
4, 3 plus 1, 2 plus 2, and 1 plus 1 plus 1 plus 1.
I agree with all of those, but I definitely think there is something missing. So I'd like to ask if anybody had a 5th partition for the number 4. This is harder than it looks. Avery, what did we forget?
1 plus 4. Or no?
1 plus 4 is 5. And remember, we always start with the higher number when we do partitions. Tess?
1 plus 3.
We've already got 1 plus 3, right? Sabrina,
2 plus 1 plus 1.
oh my gosh. Everybody Sabrina, did you just partition that 2 to the 1 plus 1?
Mm-hmm.
That's so cool. So guys, thanks to Avery and Sabrina and Brennan and Tess and Aaron who got it as well, we found that we have how many partitions?
5.
And why don't you go to page 3 and write down 5 for the number 4. Now, can anybody make a guess as to how many partitions there will be for the number 5? What do you think? Aaron, what's your conjecture? Aaron, based on this,
6.
you think 6. And Avery, what do you think?
Yeah, 6.
And
Six.
and Sabrina, what do you think?
7.
And Brennan
8.
and Tess.
7.
All right. So if I were looking at this, I would have said 7. Let's try this and let's write it out. And let us, you know what? I'm going to let you look at the partitions for 4. Everybody write down partitions for 5. All right. Get going, everybody. Ooh. Remember, it's better to be thorough than to go too fast. Thorough means complete. And Avery, I know you got it, and I want you to check to make sure that there's nothing missing. Okay. All right. So how many, Brennan, did you come up with?
I came up with 6.
You came up with 6. So maybe our thing was wrong when we said 7. Avery, what about you?
I got 5. Or no,
Got
I got
5.
Yeah, I got 6.
I'm sorry, Avery.
5. What?
I could not hear what you said, my friend.
I got 6.
You got 6. Really,
5.
it's the same thing as Brennan. What about you, Aaron and Sabrina?
I got 6 too.
And was that Aaron that just said that?
Yeah.
Okay, what about you, Sabrina?
I got 6.
And Tess?
7.
Oh, interesting. So, Tess, why don't you go through yours? And I want everybody else to watch what Tess does. Go, Tess.
5. 4 plus 1. 3 plus 2. 3 plus 1 plus 1.
Oh, and that was the one that was like the one Sabrina did, right? which when she partitioned the 2 to 1 and 1. Cool. Keep going.
2 plus 2 plus 1.
Wow.
2 plus 1 plus 1 plus 1. 1 plus 1 plus 1 plus 1.
How many did you guys figure out which one you missed?
Mm-hmm.
Now, which one did you miss, Avery?
I missed the 2 plus 1 plus 1. I got 4. I got 5, 4 plus 1, 3 plus 1 plus 1, 3 plus 2, 1 plus 2 plus 2.
Interesting. What about you, Aaron?
I didn't do the 1 plus 1 plus 1.
Oh, you mean the one on the bottom?
Yeah.
That's always going to be the last one, Aaron. Isn't that cool? That's always going to be the last one. Brendan, which one did you miss?
I missed the 2 plus 2 plus 1.
Yeah, I think that one is a little tricky. Tess, which one did you not miss?
I don't know.
Now,
None of them.
everybody go to page 3, and we were right. Now, who can tell me the next one? Please don't say it out loud. But this time, whatever you think the answer is, I want you to say what you wrote down. So write down your guess. It's called a conjecture. And right now, tell me what it is. On 3. 1, 2, 3, conjecture.
9. 8.
8.
9.
Avery, no, don't repeat it. Avery?
9.
9. Brennan?
9.
And Aaron?
9.
9. All right, I'm going to put down 9. And why don't we now go back here and everybody partition 6 and see if we get 9, which does make a lot of sense. And I want you guys to try to follow this algorithm, and you never go to a different partition unless you need to. You never go to a different partition unless you need to. Mr. Kramer's going to go to the restroom, and I will be right back so you guys get them all done and then count them. All right. So how did everybody do? Did anybody get 9? Big hands up. Did anybody get less than 9? Did anybody get more than 9?
Got more than 9.
Wait, you got, so Tess, I thought you got 9.
No.
How many did you get, Tess?
Um,
And Avery? And Brennan?
11.
11? And Avery? Avery, I can't see you, buddy.
I'm counting them.
Oh, you're counting them. And how about you, Aaron?
7.
7. All right. Brennan, why don't you read yours on this one?
6. 5 plus 1. 4 plus 2. 3
Whoa,
plus
whoa, whoa. 5 plus 1, 4 plus 2.
3 plus 3.
Uh-oh. Are you really done with your 4s? Wait a minute. Before you say it, Brennan.
Oh.
Before you say it, Brennan.
No, 4 plus 1 plus 1.
Wait a minute. Hold on. Did everybody get 4 plus 1 plus 1?
Yeah.
And I really want to call that one the Sabrina, because remember at the very beginning, she partitioned the number 2 into 1 plus 1. So don't forget to do that. Now, Avery, why don't you take it from there?
4. I thought it was 4 plus 1 plus 1. Aren't we doing 7? 4 plus 1 plus 1 plus 1.
Aren't
Oh,
we
we're doing
six?
6 right now.
Yes,
We're doing
yes,
6.
yes. But that's
Oh.
that was a good clarifying question. Very good. Sabrina, what's the next one?
3 plus 3.
I totally agree. And Tess, what'd you get for the next one?
3 plus 2 plus 1.
And Aaron, what'd you get for the next one?
3 plus 1 plus 1 plus 1.
Ah, nice. Wait a minute. Did I have too many ones here?
Yeah, that's all the ones.
That's all the ones. And now, who has not given me their thinking on the next one? Was it Avery?
What?
Avery, what's the next one?
2 plus 5. No, we're still doing 2 plus 3 plus 1. Or did we already do that?
You tell me.
Yeah, we did.
But remember, the numbers always have to be the same or smaller. Aaron? Aaron?
2 plus 1 plus 1 plus 1 plus 1.
I do not agree that that's the next one, but I do agree with what you said. Brennan?
2 plus 2 plus 2.
Ah, you always want to use the biggest numbers possible. And so now, Tess, what'd you get for your last ones?
2 plus 1 plus 1 plus 1 plus 1.
I do not agree. I do not agree, but I like what you did in any event. Sabrina, what do you think? Remember, never partition a number until you have to.
I mean, what we do, yeah, I mean, I think
I don't really know.
I think, you know.
All right. Tess, do you want to amend it?
2 plus 2 plus 1 plus 1.
So Sabrina, do you see that we need to use the 2 again and then use the Sabrina method to partition 2 to 1 plus 1? And then everybody, what's the next one? Go. Go.
You know exactly
1 plus 1 plus 1 plus 1 plus 1.
And that is the second to last one. And everybody on 3. 1, 2, 3, go.
1 plus 1 plus 1 plus 1 plus 1 plus 1.
Now, do you guys see what I wrote there?
Yeah.
That is special notation. So instead of writing 1 plus 1 plus 1 plus 1 plus 1 plus 1, you would just write in parentheses a 1 with, it looks like an exponent, but it's called a superscript. Can you guys say superscript?
Superscript.
Now, let's see if we can write out the next one. The next one is really 6. We'll do that at the beginning, and that's just a 6. The next one is 1, 5, and a 1. So that's just 5, comma 1. What would the next one be?
4, 2.
Now, what would the next one be?
4, 1, 1.
No,
No, 4,
1, 2.
no. It's a 1, but how many times?
2.
So it would be a 4, comma 1 with a superscript of 2. Write that down. Now, the next one's kind of fun. How do we do that next one? Go ahead, Avery.
3, 3, or no,
No,
3, something.
no, no comma. No comma. Test.
3 superscript 2.
Yep. 3. So we can even say 3, 2. We can even say 3, 2. Aaron, are you looking up at the screen to see that? All right. So that's 3 superscript 2. Now, the next one's kind of fun. Why don't you guys write down the next one? All right. I want the next one, Sabrina, and the one after will be Avery. Go, Sabrina.
I still haven't figured it out yet.
But honey, are they all different?
Mm-hmm.
What happens when 4 and 2 are different? 4, comma 2. What happens when 5 and 1 were different? 5, comma 1. What do we do with 3, 2, and 1?
3, 2, 1.
You are awesome. Avery, what about the next one? And Aaron, you're going to be doing the one after.
3, 1. 3 superscript 1.
Yeah, no, but that's a good try. How about you, Aaron?
3 superscript.
Nope. 3. There's only one 3, guys, so it doesn't get a superscript. All right, Tess.
3, 1, 3.
That's right, everybody. It's a 3, 1, 3. 1 has a superscript of 3. Now, the next one, Aaron, you should do the next one. Come on, there are 3 2s. So what do we do?
3 superscript 2.
Nope. That would be that one. Aaron, come on. It's 3 2s, not 2 3s. Come on, Aaron, you can do this.
3,
No. The number is 2. The number is 2.
2 Superscript 3.
Exactly. And Brennan, can you do the next one, please?
Okay. 2, comma, wait, no, 2, wait, 2, wait, 2, comma, 2.
And Aaron, I want you to watch this, buddy.
2, comma, 2.
No, no. Come on, somebody help him out. Come on, Avery. Avery, you do this one. Go ahead, Avery.
2 superscript 2. 1 superscript 1.
You mean comma,
Oh,
1
yeah.
superscript. Come on.
2.
2. Aaron, do you see it? Aaron, there are 2 2s and 2 1s. Avery, do you see that?
Yeah.
There are 2 2s and 2 1s. Brennan, you see that? All right. Sabrina, can you do the next one?
2, comma 1, superscript 4.
Amazing. Now, do you guys think that you could do, well, first of all, how many partitions were there?
1, 2, 3, 4, 5, 6.
Don't say it out loud. On 3, 1, 2, 3.
11. 11.
Oh, so everybody go, and we're going to erase the 9. And I want to ask you guys a question. Do you guys see a pattern?
No.
Yes.
What are those numbers? What are those numbers?
Even, odd, odd, odd.
That's true, 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 true. Tess, what do you see?
I don't know.
But even odd, 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 Brennan, doesn't predict the next number. Who sees a pattern? These numbers all have something in common. Avery?
Maybe it's each one is 2 up, but it can't be 2 up on 7 and 11.
They are all very special numbers, guys. And write this down. They are all prime numbers. Prime numbers can only be made with multiplying 1 times that number. So 1 times 2 is 2. 1 times 3 is 3. 1 times 5 is 5, and 1 times 7 is 7, and 1 times 11 is 11. You can't make those numbers any other way with multiplication. They're called prime numbers. So what do you think the next prime number is going to be? And let's see if that's the answer for 7. What do you guys think? Any ideas about the next prime number? A number that can only be divisible by 1 and itself. Who wants to take a guess, a good educated guess? Aaron, Sabrina, Brennan, Tess, Avery? What do you think, Avery?
Maybe 17.
Ooh, 17's a good one, but that's not the next prime number. That is a prime number, but there's one in between. Who knows the prime number that's in between 11 and 17? Brennan?
15.
Oh, but 15 equals 3 times 5. So it's not a prime number. Sabrina, what do you think? It's between 11 and 17. It can only be divided by 1 and itself. And it's not 15. It's not 7. It's not 17. That's not the next one. That's prime though. Aaron, you have it?
13.
Oh, Sabrina, you nailed it.
13.
So everyone, let's see if there are 13 solutions. However, when we do this one, I am going to want you guys to just do the notation that I just taught you. So instead of writing the plus signs, I want you to give me the partition notation for the number 7. So for the first one, you would just do parentheses and the number 7. The one after that, you would do 6, 1. So you guys get to work, and I'm really excited to see if everybody can get it done. Yes. All right. Do you guys, how many did you guys get? Oh, wow. So guys, is it harder or easier to do it
Harder.
with partition notation or with
Harder.
plus signs?
Partition mutation.
So you'd rather
Partition
do-
notation.
So you'd rather do plus signs?
Yeah.
Okay, I got you. We can do that. So let's do 7 and 6 plus 1. And what's the next one, guys?
5 plus 2. Wait, no, 6. Wait, yeah, 5 plus 2.
And wait, let's go in order. Let's go in order. We're going to do Avery next.
5 plus 1 plus 1.
Sabrina.
4 plus 3.
Wow. Nice. Brennan.
4 plus 2 plus 1.
Wow. Tess.
4, 1, 3. 4 plus 1 plus 1 plus 1.
Wow. Fantabulous. And Aaron. This next one is a little difficult.
3 plus 1 plus 1 plus 1.
That is, well, that's not 7. That's only 6. But that's not the next one. So what we're going to do here, we're going to go to single page. And Aaron, think about it, buddy. You want to go to the highest possible number. What's the highest possible number that you can add to 3 without going above it?
3 plus 2 plus 3.
Louder, please.
3 plus 2 plus 2. Or
That is true. But before you do that one, come on. Who's got another one? Come on, Sabrina. Or let's go with Brennan or Avery.
3 plus 3 plus 1.
So Aaron, do you see that one? 3 plus 3 plus 1. And then everybody, it's 3 plus
3 plus 2 plus 2.
plus 2. And then
3 plus 1 plus 1 plus 1.
No, never, ever add a new partition unless you need to.
3 plus 2 plus 1 plus 1.
And what's the last one for 3?
3 plus 1 plus 1 plus 1 plus 1.
Nice. And now what's the next one? Who's got the next one? Sabrina, do you have the next one?
No.
Tess?
No.
Okay, I thought you had your hand up. Avery. Go, Avery.
What?
Go, Avery.
Okay. 2 plus 3 plus 1 plus 1.
2 plus 3 plus 1 plus 1. Remember, we never go up. 2 will always be the highest number on that row. Brennan?
2 plus 2 plus 2 plus 1.
There are 3 2s and a 1. Combinatorics is fun. Aaron, what's the next one?
2 plus 1.
No, you do
2
not.
plus 2 plus 1 plus 1 plus 1.
Nice. And who can do Brennan? Who can do the next one?
Okay. Let's see. 2 plus 1 plus 1 plus 1 plus 1 plus 1.
And this is a situation, guys, where the partition notation, wouldn't that be so much easier to say 2 comma 1? 5.
Yes.
Wouldn't that be easier? And then the last one would be really easy because you would just need to say what?
1
1.
7.
1 7. But we have to go 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. And now, don't yell it out, but let's see the counting. Aaron, come back to us. How many partitions?
5, 6, 7,
Aaron, stay
3,
with us
4,
and
5,
unmute
6,
yourself.
7, 8, 9,
Don't say it out loud.
13.
15.
Don't say it out loud. On 3, 1, 2, 3.
13.
15.
Guys, you did not get 13. You
15.
got 3, 3, 3, 3, and 3. 5
15.
threes make 15. So there are 15 partitions for the number 7. So when we were thinking that it could be the prime numbers, unfortunately, that was just a coincidence. So the next one is in fact 15 and not 13. Now, what do you think the next one is going to be? Who has an idea? Write it down and then tell me. And then we're going to find it together. All right, Aaron.
17.
Well, I like it because it's a prime number. But if you're looking at this sequence, I don't know about that. Tess, what do you think?
19.
19. And so I've got a 17. I've got a 19. Anybody else want to take a educated guess? Go ahead, Avery.
18, maybe it's between those.
What do you think, Sabrina? Brennan
I also think 19.
and Brennan.
21.
Ooh. All right. I'm going to tell you a little hint. Brennan came the closest, but nobody got it right. So I want everybody now to use the plus notation, and let's see what you come up with now for partitions for the number 8. All right, let's see what you can do. All right, everybody stop because we know we're probably not going to get it done beforehand, but let's do it as fast as we can. Start with you, Aaron, then Avery, Sabrina, Brennan, Tess, and we keep going. All right, ready, go, Aaron. All right, I said 8, but I couldn't hear you. Avery.
7 plus 1, 6 plus 1 plus 1.
No, not yet. Sabrina.
6 plus 2.
And what's the next one after that, Sabrina?
6 plus 1.
6 plus 1 plus 1.
There you go. Great. Brennan, give me 2, and then come back to Aaron, and Avery will give me 2. Go, Brennan.
5 plus 3, 5 plus 2 plus 1, 5 plus 1 plus.
5 plus 3, and then give me one more.
5 plus 2 plus 1.
Oh, beautiful. And Tess, give me 2.
5 plus 1 plus 1 plus 1. 4 plus 4.
Oh, sweet. Aaron?
4 plus 3 plus 1.
And Avery. No, give me one more, Aaron.
4 plus 2 plus 1. 4 plus 2 plus 2.
Perfect. Avery?
4 plus 1 plus 1.
Wait a minute. Hold on. Avery, do you need to change this 2 for the next one?
Okay. 4 plus 3 plus 1
No, it's 4 plus 2 plus 1 plus
plus
1.
1.
So you never change the number until you have to. And now, Sabrina.
4 plus 3 plus 1.
We already have that one, right? So now you got to partition that too.
4 plus 1 plus 1 plus 1.
Plus 1. And Brennan,
3 plus 3 plus 2.
3 plus 3 plus 2. Now, everyone watch this. We're going to go 3 plus 3 plus 3 plus 3 plus 1 plus 1. And then, come on, guys. And then 3 plus 2 plus 2 plus 1. And then 3 plus 2 plus 1 plus 1 plus 1. And 3 plus 1 plus 1 plus 1.
Plus 1.
And plus 1. And then we do the 2's. Now, there are 22 partitions for the number 8. There are 22 partitions for the number 8. And believe it or not, there are 30 partitions. You can write this out for the number 9, and I want you to find all of them. So I hope you have a lot of fun, work really hard. I will see you in 2 weeks because we have winter break coming up, and I want you guys to say goodbye to your friends, and
Bye.
we will be there in a minute. Oh, hey, Roman. How you doing, buddy?
Bye.
We're gonna be going to another class in just a minute. So sign in, Roman, to the other class, please. Okay, and you too, Raymond, and you too, Jeremy.
What other class?
The 4:30 class. Jeremy, were you supposed to be on this one?
Yeah.
Oh, so you just missed it. Let me see if there's a way that I can get Jeremy or Raymond to join that class. And Roman. We'll see what we can. Roman, you just go with because you were supposed to join at 3:30. You were supposed to join at 3:30. All right, bye guys.
Bye.